Welcome to Chem Help ASAP. Let's define MO theory and molecular modeling. MO theory, or molecular orbital theory, is a way of understanding molecules and their reactivity. How does MO theory work? MO theory sees molecules as a collection of atoms with orbitals and electrons. For example, methane contains a carbon atom and 4 hydrogen atoms. Each atom brings in electrons and atomic orbitals. MO theory uses mathematics to approximate the atomic orbitals, the wave functions, that's Greek letter psi, of the atomic orbitals. The atomic orbitals, AOs of different atoms, are mathematically combine to form molecular orbitals, MOs, as wave functions, psi again. Once you've predicted the molecular orbitals, you add electrons, and now you have a mathematical model of the molecule according to MO theory. The model allows you to predict chemical reactivity and properties. Wonderful. Okay, we are not experts on MO theory, but these are the basic ideas. Take your atomic orbitals, mix them together, and construct new molecular orbitals, add electrons, and you're done. MO theory is just one approach to molecular modeling. Chemists model molecules to predict the shape or reactivity of a structure. MO theory makes predictions based on constructing the molecular orbitals of a molecule. MO theory is good at making reactivity predictions. But MO theory requires a lot of computer power. It's hard to work through these mathematical equations. You need special software to do MO theory calculations. There is another type of modeling, molecular mechanics. In molecular mechanics, molecules are treated as rigid spheres and flexible bonds. Molecular mechanics is really good at predicting molecular shape and conformations. Molecular mechanics requires less computational effort and therefore can be used on large molecules. That includes even proteins with potentially thousands of atoms. For this playlist, we will only be discussing MO theory-based models, but there are other ways of understanding molecular structure.